Hello, everyone. Good afternoon. My name is Daniela Rus. I'm the director of the Computer Science and AI Lab at MIT, CSAIL, and I'm thrilled to welcome you to our Hot Topics in Computing. And in particular, tonight, I'm thrilled to welcome Kevin Scott, who has one of the most interesting jobs in technology right now. He is the CTO, the Chief Technology Officer of Microsoft. And he is helping steer the technical vision behind every product at Microsoft, from Azure to AI. And he's doing this at a moment when all those decisions matter deeply to the world. Now, Kevin's path to Microsoft has covered pretty much every layer of computing. He started at Google, where he helped build and scale the search and ad systems. And, we all take advantage of these systems. We're all users, and not just us, but billions of people on our planet are users of these systems every day. And then he was at LinkedIn. He was the SVP of Engineering and Operations. And he helped grow the company through its IPO and through years of hypergrowth. And this is really extraordinary. He built teams and infrastructure that power the professional networks we're all part of. Now, today, Kevin spends his time thinking about how to make AI useful to everyone and how to make Microsoft an exceptional place for engineers and researchers. Within his spare time, he does all sorts of other extraordinary things. So, for instance, he hosts the Behind the Tech podcast, where he really turns the spotlight on other technologists, and he does it with panache and with charm. And I say so as someone who was on the podcast with him maybe a year or two ago. He's also the author of a book called Reprogramming the American Dream. And this book is about how AI and technology could expand opportunity rather than shrink it. And I learned recently that this book was the #1 Wall Street Journal best-selling roadmap to work and hope. On top of that, Kevin sits on Shopify's board. He advises startups, supports nonprofits, and still somehow finds time to be a computer scientist with patents and research and long-standing interest in everything that has to do with computing. Please join me in giving Kevin a very warm CSAIL welcome.
Thank you. Thanks.
So, so here's what we're going to do. We're going to talk for about half an hour. We'll see how it goes, and then we will open for Q&A from you. So please think about your best and most important questions for Kevin. So, Kevin, let me start by saying that many of our students grew up far from tech hubs. And you also grew up in a small town in rural Virginia. And you talked in the past about finding your way from rural Virginia to computer science almost by accident. Can you share with us a bit about your trajectory? Are there special moments that stood out along the way?
Yeah. Well, I think we're in a special moment right now. We were chatting about this earlier. So I guess I was lucky enough to be like a young person when the personal computing revolution was happening, and it, like, for someone who was curious, like, that was the most interesting thing in the 80s to be curious about, like, to my sensibilities. And I think the interesting pattern that I see over and over again, like, it's certainly been true in my career, and it's been true for like a bunch of other successful people I've interacted with, is like having high curiosity and like being able to learn as much as you can when technology is dramatically changing and like the world around it is changing is like a good characteristic to have. I mean, like part of whatever success I've had is just attributable to luck, to like, you know, being that curious young kid then when so much was changing and basically getting an early start on things. And so like I
What
think
was
with
your first computer? Speaking of the
it
early
was
start, do you remember?
it was a Radio Shack Color Computer 2, which I worked a bunch of odd jobs, you know, saving up for. Like, this is really dating me. Like, I'm about to be 54 years old, and so, you know, like I cobble together a few $100, and like it's one of these like beige case computers with chiclet keys, and like the particular one I had, because we were broke, like used a cassette tape recorder to store and load computer programs from it, and like your monitor, like my monitor was like some crappy little 13-inch TV that I hooked it up to. But you know, it had a built-in, like you know, the thing that was amazing about computers back then is like they were all programmable by default. So you turned it on and like you like had a basic interpreter prompt, and so like the first thing that this computer was doing was inviting you to program it. And I think we're like a little bit in that moment with AI right now. Like the most interesting thing about AI is like its invitation to assist you in programming, to like, you know, say like, hey, I'm here to help you create something. And like I think that ought to be, you know, I know it's like anxiety inducing to some people, like, you know, including folks like me. I love actually understanding how my tools work, and I'm kind of set in my way in a bunch of different dimensions. But like if you have a thing that you're trying to get done, like it is unbelievably compelling right now, like how much individual leverage you have over being able to like will that thing into existence. Like whether it's like this is a super random thing. Like I spend a bunch of time on my weekends doing pottery now, of all things. But like I can't help myself but want to make my own tools for doing it. And so like I'm building a potter's wheel right now that's like a hybrid electric kick wheel. And like we're using AI coding for the firmware on
You're
this
building
thing.
a robot.
Yeah, it's basically a robot.
Great, you can
Yeah.
come and work with
Yeah,
us.
it's got a servo motor, torque sensors, like, you know, sort of like all sorts of like weird controls. But like the only way that something like that is doable for someone like me on weekends is like you have a coding assistant that can help you do the firmware for it. Because otherwise it would take like 5 times as long as I actually have, and like I would just be out of time budget for it.
Oh, that's amazing. You also need some in situ AI that can run your
We may.
So, Kevin, when you if you're thinking about all these students who are here today, who are just starting out, now, if you were one of them, how would you be looking at this special moment in technology?
Well, I think learning as much as humanly possible about a landscape that is changing very rapidly is is a good thing. Like making sure that you're opening yourself up and like being flexible in your curiosity, because like the rate of change is like I think, and maybe this is bad news to some folks, like I think it's going to go up, not down. Like the next 12 months is going to be, you know, even more change, more interesting things happening on the software development front than the last 12 months, and that's saying something, because I think we've had a radical change just over the past year. But you know, there's a whole bunch of, you know, foundational things about being a computer scientist that are more important now than ever. Like one of the things that we're seeing with teams who are not budget bound with how they're able to use these AI coding assistants. So like they've got all the budget in the world to like go use as much AI coding assistance as they possibly can. The thing that happens with them is they become attention constrained. So they like start doing stuff at such a high level of complexity and like so many things in parallel that they run out of the ability to keep track of everything that's going on. And when that happens, like we know this because this is like a common pattern with human cognition, like modularity, composability, interfaces, like we're going to need a new set of abstractions to, or like maybe this same old set of abstractions that we've had to help us manage like wielding this tool, in a really ambitious way. So, if anything, like maybe some of the vocational bits about computer science education are changing a little bit, like, the nature of the actual, the compiler, so to speak, the programming language that's, in vogue is like now AI coding assistant. But like the core principles of, like how do you really have good judgment and good taste about the problems you choose to work on? Like, how do you like do a really good job as a systems thinker? Like, how do you, learn how to assemble all of these pieces that these AI coding assistants are allowing you to create? Like, super, super important. And then the other thing too is like just giving yourself, permission to go latch yourself on to whatever rocket ship you can find to be on. And like there are going to be lots of rocket ships over the next handful of years. The other good bit of luck with me, and like I didn't always realize when I was getting on a rocket ship, is like I had very good fortune of like getting myself into like very high growth companies. And like when you're in a high growth place, like if you are just the barest bit competent and the barest bit curious, like you are going to like grow along with the institution that you're in.
Your first big job was at Google. How
Yeah.
did that happen?
Random.
Random.
So like I wish I could tell you it was like a brilliant decision, but like I was a PhD student at the University of Virginia, and I was a compiler and computer architecture guy, and I was broke, and I needed a job, and I had decided, like I thought I was going to be a college professor, and like I decided that like maybe I wasn't going to be a college professor, and so I needed a job in industry, and I knew that a bunch of my compiler buddies from academia had joined Google. So Urs and Alan Eustace and Jeff Dean and like, all of these folks who like either knew my PhD advisor or like I met at, conferences like PLDI, had for some reason that I did not understand at all joined Google. I had no idea why a compiler person would want to go to like this search engine company. And at the time it wasn't public. Like I didn't know whether they were ever going to make any money. Like I was so stupid that when I was negotiating my my package there, I was living in Germany teaching computer science at the University of Göttingen at the time because my wife was a historian and she needed to be in Germany. I spent all of my time, rather than negotiating up my option package, like I was negotiating for like an extra $5,000 to help with relocation. I mean, it was like horrific. But like I had no idea. Like I thought I was just going to this company to hang out with these cool compiler people. I didn't know whether Google would be in business a year later. And so like that was luck. But like the thing that I learned immediately when I got there is that like they're just huge career benefits and just lots of fun to be had if you are at a high growth place. So I just raised my hand every time when someone was looking for someone to go solve a weird problem. Like as long as I thought the problem was relevant to Google's business, that it was like a necessary thing, like even if it wasn't my area of expertise, I would raise my hand and say like, hey, I can go help with that. And like I just learned a ton that I would not have learned in any other environment. And so like that's the benefit of like, just finding yourself a rocket ship wherever it is. Like, and rocket ships don't have to be a company like Google that are gonna like end up being as big as Google's end up being. It could be joining a startup. It could be like joining a super high growth team inside of a big tech company. But like you just want something that's got trajectory.
So what did you not understand about careers in high tech back then that you wish someone had told you?
Uh, well, look, there were a bunch of things I didn't understand. I'm sure there are a bunch of things I still don't understand. I didn't really understand that, like most things that are, and this is even true with AI coding assistants and whatnot, almost everything valuable that's worth doing requires coordination across lots and lots of different people. And like there are just a bunch of lessons that you learn trying to do stuff inside of large teams of people. Like, like a good one, like not the only one, but a good one is I had a mentor at one point ask me to imagine a histogram that's got 5 buckets in it, and the bucket all the way on the left is idiot, and the bucket all the way on the right is genius. And you can take every every characteristic or quality that you have, and you can put it into one of those buckets. And then the thought experiment is, with great effort, you can move one of those qualities or characteristics or skills one position to the right. And the mistake that lots and lots of people make is like they spend inordinate amounts of time trying to take things where they're below average and like getting them to the right. And with great effort, like they can make themselves average at those things. And every minute that you spend doing that is a minute not spent doing the things that you're above average at. And so that's a really important thing to realize about yourself, because your ego sometimes doesn't want you to be below average at anything. Like, you want to be great at everything. It's also a super important thing to understand about teams. Like when you're composing a team, the important thing is like you've got a genius on like every one of the tasks that the team needs to do to like get the problem solved. It's not that every member of the team is a genius at everything. And so, just being super careful about like how you compliment yourself. Like there are all sorts of things about being CTO at Microsoft where a different CTO would do the job in a different way. Like there's just a bunch of things that I absolutely hate. And what I do with those things is like I get good people onto my team who love doing those things and who are very good at them, and then they go do them. And it frees me up to go do the things that I enjoy more and that I am better at. And it's okay to do that.
One example?
Oh, I hate bureaucracy so much.
Okay, so how do you manage that?
I have a deputy who is really good at that. So at budgets and facilities and finance and HR and like all of these things where everybody would, want me to spend hours and hours and hours out of every day, like sitting in meetings, like making these decisions that are important to get made, but like I'm not good at making those sorts of decisions, and I hate doing it. And so she goes and like does a masterful job at those things.
So on the flip side, what are some of your most favorite things in your current role?
Well, I'm maybe pathologically curious, so I like to know about as many things as there are to know. And so, and it's good in the way that I do my job at Microsoft is I am looking at things that are so broad that they don't neatly fit into one of the engineering organizations like wholly. Like the reason that I've spent so much time over the past handful of years doing AI work is that AI doesn't belong just in Azure, and it doesn't belong just in Office, and it doesn't belong just in gaming. It touches everything that Microsoft does, and there was no one natural engineering leader who could grab all of AI and say, like, we're going to do this for the company, and like everything is going to get done super well. And so like a lot of those horizontally cross-cutting things end up under me, like where I spend like active time every day thinking about them, running programs, recruiting, managing capital budgets. And then, my time horizon also tends to be a little bit different than some of my colleagues. Like there's some people at Microsoft who like really, really, really like existentially like have to get a bunch of complicated things done on 3-month and 1-year time horizons. Like it's just critically important. And so they end up spending huge amounts of their time like thinking about how they like get delivery done on those time horizons. And they still think about the future, like what's happening 5 years from now, further out. But like I tend to spend like kind of the inverse of my time. So I spend most of my time thinking about what are we doing or not doing right now that like if we don't get right, we're going to really regret it in 5 years, or and like a handful of things that are like short time horizon.
So let's take you from your very important current role at Microsoft and imagine you're a 20-year-old student at MIT today. What's one thing that the 20-year-old Kevin Scott didn't even know to dream about that you could now imagine doing with AI?
Like lots of stuff. I think the interesting thing right now is it's never been clearer that you don't need to believe or expect for expertise to be gatekept or inaccessible. Like I would, if I were you all, I would be absolutely fearless, like diving into new things. Like even if you're not expert at the thing or there's some aspect of it that requires expertise that you don't have. And like even if you don't have proximity to an expert. Like it was one of the things that was frustrating about growing up in rural Central Virginia in the 80s is like they just, there was no internet and there was no proximity to expertise. And so there's just a lot of fumbling around in the dark trying to figure things out. Like that's not necessarily a thing that you all need to struggle with in 2026. And it's not to say that like AI is going to give you like perfectly accurate expert advice, but it's going to get you onto like a bunch of interesting trailheads that might have otherwise been too expensive to get to if you didn't have it. And I think you should let that give you courage to do more ambitious things than you otherwise would have considered possible. Like I watched my 17-year-old do it, so like I have a little bit of a clue of maybe what 20-year-old Kevin would have done, because like I've got a 17-year-old little mini me who's doing some of this stuff, and like she's just. So I was in Japan last week. This is a funny story. So while I was gone, this child takes over part of my workshop, and like it's just wreckage all over it. Like when I come back, because she had been synthesizing silver nanowires in my lab, because she's doing research at the cardiothoracic research lab at Stanford, and like she needed a bunch of silver nanowires for installing in the cardiac tissue of lab rats. And like she thought that the best way to get these silver nanowires was she was just going to make them in my lab. And like a lot of her courage to do something like that is because like AI can like help her get to like the right trailhead. So it's like, okay, like what's the next step? Like what's the next paper I need to go read? Like this paper's got something, weird in it I don't understand. Like help me understand this. And like lo and behold, other than wrecking my workshop, like she successfully synthesized a bunch of like silver nanowires, which I don't even know whether like me at 17, like not possible, like on many dimensions. Like I don't think I could have done anything like that.
But this is actually consistent with the Copilot ethos that you've been
Yep.
leaning in. So use AI as an amplifier
Yep.
rather than as a replacer.
Yeah.
And so when I think about that, one question that pops in my mind is, how do you do this while honing in skills so that you don't end up allowing your skills to atrophy?
Yeah, well, look, I think for like a whole bunch of things, like you actually have real world proof points. So the synthesis she was trying to do could have failed, and then she'd be back to square one. And like, you know, she would have had to have had some way to like have a feedback loop to understand what went wrong and enough understanding of what was going on to like run the next turn of the crank. And so I think there are just a bunch of things like that where like, and, you know, I've seen it myself with some like weird experimental things that I'm doing, like in the craft stuff that I do on the side, where you know, like I've been researching uh, medieval Japanese pottery techniques, and you know, like AI, like kind of isn't great at that. It's sort of good at getting access to materials that are written in Japanese that I can't read, and it's good at, you know, sort of kind of getting in the ballpark of some things, but then it's horrifically wrong about a whole bunch of other things. And so, like, you need to be able to, you know, really get in there and, you know, parse out, like, you know, what the useful bits are so that you can actually formulate an experiment that you want to run. And then the experiment is the truth. Like, that's the thing that will tell you, like, okay, like I'm getting closer, like, you know, here's what the next iteration is. Even with software development, by the way, like that's the, you know, the core of the AI software development loop has to be like one of these experiment cycles. Like you have to know at the beginning, like this is the thing I'm trying to do, this is why it's important, and this is how I will know if I've succeeded. And like that is part of the schema of development, and like hopefully it ends and like you pass this thing off to someone who's going to use it, and like you get some feedback that tells you whether you got close or not. And if you aren't, like that gets fed back into the beginning and you turn the crank again. And at some point, if you get stuck, like you actually have to have some kind of diagnostic ability to figure out, like, you know, what's going on here. But this is kind of the way engineering's always worked. So like there's no cheat code here. Like you all have to know how to think. Like you actually have to know how the world works. Like you have to know what to do when you run into a brick wall.
So we still have to know stuff, and we still have to learn computer science.
Yeah, I think you really do. Like, please.
Okay. So related to this, I'm sure a lot of people here want to know how to get a good job at Microsoft. So when you're evaluating early career candidates, what do you look for now that you were not looking, let's say, 10 years ago?
Oh, look, I think we're looking for I'm looking for the same thing across the board. Like I'm looking for folks who have a lot of intrinsic motivation, who are curious, who want to learn and who have the capacity to learn. Yeah, funny enough, one of the things I've always said about MIT students is, like, no offense to computer science professors here, is like, you all teach undergraduates like a whole lot about computer science that's useful, but like the more important thing is like you teach them how to work. So like MIT students like come into companies and like they're just not daunted by having something complicated put on their desk where they don't know all the answers. And like that's what work is. Like it's being presented with a challenge where we don't know what all the answers to this particular problem are, and like we're hiring you because we hope you can figure out how to get to the answer. So yeah, I mean, that's what we're looking for. We're looking for evidence that you are able, like on your own motivation, to go out and solve complicated problems. It's less about your GPA or like which courses you took, but like real evidence that you can get real things done.
What about AI literacy? Is that important to have on your CV?
Yeah, look, I think it is. Like, but it's important in the sense that, like, what we don't want to see are folks coming into the environment where they're going to be averse to like using the tool chains that we have. So like I do think it's a good sign right now of curiosity for any graduating student that like you are like trying to figure these tools out and like you're using them for like things that matter to you. But you know, it's not like okay, like you're not going to get a job because like you're using OpenAI codecs instead of Anthropic Claude code.
But are you looking for a strong AI literacy in the form of big projects or independent work?
Yeah, look, I think the more ambitious either class projects or independent things that you're doing, whether they're using AI or not, are good indicators. Like I think ambitious things, in 2026 probably benefit from AI. So it would be an unusual thing. Like it would be a question I would ask for a candidate if like they had a big ambitious thing that they'd done and they hadn't used AI on it. Like I would be curious to understand why they hadn't. And it's not that it would be a disqualifying thing. It's just like I'd be genuinely curious, like why they thought that was the best way to go about solving the problem. And if they had a good answer, then they're hired, right?
Yeah.
So like I don't think there's anything that we're being dogmatic about right now. Like we just want to see people who like have some passion and ability to deal with complicated things and flexibility. Like they're not going to be overwhelmed by a lot of change that's coming.
Well, I hope you took notes. Kevin, you sit at the intersection of huge compute, huge models, and huge responsibilities. So, what keeps you up at night that our students should care about?
Yeah, lots. I mean, I do have a pretty high degree of compassion for people dealing with the rate of change right now. It's just sort of a lot happening. One of my closest friends is a CTO of a game startup right now, and the way they organize themselves is in 6-week sprints. And he called me right before Christmas, and he was like, "Dude, I went into like this sprint feeling totally caught up on everything that was happening in AI assisted code development. I put my head down for 6 weeks to get this sprint done. I come back out and I feel like I don't know anything that's going on." And like that's disconcerting, right? Like, he basically has got 2 full-time jobs now. Like he's got CTO of this gaming startup and like trying to ship this game, and he's got like keeping on top of like this crazy like almost vertical rate of change and like the way that the industry makes software. So like I do worry about like people people adapting to change. I worry about a bunch of the potential negative uses of AI. Like I've spent a lot of time over the past handful of years, like trying to make sure that we're doing responsible AI system deployments. Like just takes a lot of time, and like it's a harder and harder job all the time. I think like building all the safety mechanisms into the models and like and surrounding the models. I kind like there are a bunch of things that you sort of know to worry about, and most of them I think at this point are like obvious things where you've got like hard problems to deal with them, but like they're all addressable. And then you've got just sort of the weird things that may happen. Like to me, the saddest thing that could happen with this new round of AI is that like we just end up using it for a bunch of trivial things, that it becomes yet another thing that is like trying to optimize like for grabbing attention, and that isn't substantive. It's honestly, it's one of the things that I worry about with the coding stuff. So it's like very, very easy right now as a software developer, if you do have unlimited budget, to let yourself feel this euphoria from the amount of productivity that you think you're having. You go from like, oh man, like I did 2 or 3 pull requests a week to like I can do 20 a day now, and like you just feel amazing because you're producing all of this stuff, and you're not paying attention to the fact that like none of what you're producing matters. Like it's all adding up to like a big fat zero, and then like the whole thing is just like TikTok for like professional software developers. So like I just like I worry about, is like we're all reacting to this amazing thing that like we are really grounding ourselves in like what's the maximally useful thing that I could go do with this rather than like, what are these trivial distracting things that I could go do with it.
So speaking of coding, are there any examples you can share with us about how engineering and product teams at Microsoft use AI that would surprise a university audience?
No, look, I don't know whether any of it would surprise you guys. Like, I mean, you're MIT, you're seeing everything I think the world is seeing. I will say, like, our teams that are using AI coding systems in a maximalist sort of way, which is like you have access to a coding model and then you have access to like frameworks that can orchestrate the coding models for doing complicated software development things. Can very easily like burn about $150,000 a year worth of token budget before like their attention gets saturated, and like nobody's touching code at all. Like you basically are writing specifications for what you want accomplished, and the system is able to generate like complete, robust, fully working artifacts with entire test schemas, and like you have deployable code that you can push out into the world with high confidence. And despite the fact that you would like to think that, or I would like to think that I'm a really, really good coder, the quality of the code that the systems are producing in terms of measured defect rates is like usually better than the best coders. But I don't think that's surprising. Like that's the thing that you all are tracking right now.
We certainly are. I'm also wondering, related to this, what has changed in how the teams work because of AI?
Well, it's really interesting. So, and this is a thing that maybe will give you all some degree of comfort. So there are places where you actually can use like a fully untethered, like budget maximized AI development team, and it's usually around things where velocity can give you a benefit. So like if you are pre-product market fit and you're trying to discover like what the right thing is to go build for a bunch of customers, like iteration speed is pretty important. So like just trying things out like very, very quickly and like getting feedback and incorporating that into like your development process is very helpful. And so like we're certainly seeing all of the places where where we can improve a product in tangible ways based on data that we're getting from deployed artifacts. Like they can super benefit from AI, but there are like a whole bunch of things that we do that have to go slow. I was telling someone this morning, like no one would really appreciate us pushing out 3 Windows kernel changes a day. That would be not good. So some things like your uptake rate on new development needs to be slow because the world wants it to be slow. You just don't want everything being changed out from under you like constantly. And so like I think it is a mix. Like it's not like one formula that works for everybody across the full breadth of Microsoft. So like some teams are like full steam ahead, like on the new tooling, like using it super productively, and then some teams are like using it in more measured ways. We are, by the way, like using it for like a bunch of interesting stuff that have been on my like engineering manager wish list since I became an engineering manager, which is we've always had this thing in software development that was strongly zero sum, which is how much of your engineering capacity do you use building brand new features that you're going to ship versus dealing with technical debt that you're accumulating. And technical debt can be like, oh, you haven't improved your infrastructure like in an architecturally coherent way, or like you've left some to-dos in your code because like you just needed to ship this thing to get some data. And tech debt is kind of like real debt in the sense that it compounds over time. So like the more you let it accumulate, it like earns interest and like becomes more miserable to retire later. And it's very zero sum because like you just have to decide like how much time am I going to dedicate to this one thing versus the other, and it's like this painful short-term versus long-term trade. Like we have a whole set of initiatives inside of Microsoft right now that are using these AI coding assistants to like help retire tech debt, and like all with the vision of like completely eliminating it at scale. So it's basically both helping you forward build great infrastructure that you need for like product deployment, as well as like sort of the cleanup pass on things that engineering teams are deploying new.
I really like that. Use agents to clean up your tech debt. I like that. I think that's a great idea.
Yeah, and I think it's the pattern in general. I mean, again, if you all are thinking entrepreneurially, like what you want to go use all of this new capacity for, like the most interesting places are where you can turn something from a zero-sum thing into a non-zero-sum thing. Because zero-sum problems are miserable. Like they're all about scarcity and constraints, and like you're always making these trade-offs that you don't want to make. And anytime you can transform a zero-something into non-zero-sum, like it gets way more interesting.
It's a good pearl of wisdom. I'm watching the time, and I just want to give our audience, our students, a chance to ask you questions. So let me pause and see if anybody has burning questions for Kevin Scott. There are microphones on the stairs. So we can hear you, or you can tell me the question and I will repeat it, but try to use the microphones. If you have a question, please line up. There are microphones on both sides.
But we can hear you.
Yeah.
Yeah, go ahead.
So I wanted to sort of two things you mentioned. One was about the rate of change, which you mentioned a few times, and the other is about how you spend a lot of time thinking about the future rather than like immediate sort of problems or like things you're working on now for the future. So I'm curious how that rate of change has sort of manifested itself in your mental models about like things you want to think about for the future, because it's like naturally harder to project out.
Yeah. So the question was, how do I think about this high rate of change and this like forward-looking, like thinking about the future part of my job, and like what, if anything, has changed about how I think about the future as a consequence? Yeah, look, I think about this all the time. One of the things that like I've been spending a bunch of my time working on the past handful of months is just agent enablement inside of Microsoft. So anything right now inside of a company like Microsoft that is not agent actuatable is going to feel broken in a couple of years. And so it requires a bunch of like really tedious like plumbing work. So it's like not the sexiest work in the world. It's not a thing anyone would look at and say, oh, like I got to go migrate, from one source code management system to another. Like it's like a handful of things that if you don't think about where you're going to be in a couple of years, you're going to be, you're just going to say this isn't worth doing. Then there are like a bunch of like even further out things. Like one of the things I think that is fairly fundamental that's changing about software with with this new generation of AI is we've been in the same paradigm for getting value out of computing devices for the entire history of computing. So it's not that much different, or it wasn't that much different before coding models than it was when Ada Lovelace was writing the first programs. So if you, a human being, wanted a computing device to do something useful for you, you either had to teach yourself how to be a programmer, or you had to find a programmer who was willing to do what you asked them to do or had anticipated your needs in some way or the other. And there are just a bunch of implications of that model about our world, like apps, for instance. Like the idea that you need someone to compose a set of features together like into like this deployable unit called an application, where they're guessing what you need the application to do, or how you should structure the application itself to make it comprehensible by a user. Like, that's a thing that may not exist in a decade. Like, you still need all of the functionality that's in the applications, but like what you're probably going to have is an agent that's doing work on your behalf that needs access to that functionality, where like the thing that we've been building for a long time, which is like this program that has a user interface, like maybe doesn't need to exist in that same form. And so like I think a lot about things like that, like what very fundamentally might be changing about the nature of software development. And like they're both things that you have, like the framework for it. Sorry for taking a long time to answer this one question. Like the Arthur Clarke wrote this book in the late 1960s called The Profiles of the Future, and like that's where Clarke's 3 laws came from. Like, you all probably know the third one, which is like any sufficiently sophisticated technology is indistinguishable from magic. So the interesting point that he made in this book is that even though he was a science fiction author, and like a futurist, and he made his career by trying to predict the future, he was trying to make this point that it's fundamentally difficult to try to make very specific predictions about the future. But like what you can understand are like some of the contours. Like they're just like, if you allow yourself to think about the future as a system, you can extrapolate from right now to like a handful of things that must happen. Like, for instance, like stuff has to be agent accessible. If it's not agent accessible in like an architecturally coherent way, like the agents are just going to route around your architectural incoherence and make a god-awful mess. But the agents are going to actuate things for sure. Unavoidable, all stop. So like that's a fairly reasonable thing that you could extrapolate about the future. Like, whether or not apps are going to exist in 10 years, I don't quite know, but it's like an interesting thing to ponder. And like, I think that's, a way for all of you as you're contemplating what to go do next, is like, there is a distinction between like what must happen and like what may happen. And like, at least whether you're right or wrong, having a hypothesis about where that line is like a useful thing, and like reevaluating on a regular basis.
So, okay, I'm sorry, but I'm going to prioritize the people who are in line. And can you please be brief so we can get as many questions as possible in the next 10 minutes?
And I will also try to be brief.
So 30 seconds, please. 30-second question.
Very sensitive microphone. So building off of your question, thank you so much for your time and speculating off the future.
30 seconds.
I promise I'll get there very quickly.
Get to the question.
A lot of us are contemplating careers in software engineering. What are some indicators in your scenario planning with your AI leadership where you're trying to understand what are the signals that you look out for where you might not need as many software engineers?
So I don't really know. I mean, so like I can tell you right now from a Microsoft perspective, like we're not having big conversations about needing less software engineers. And so the thing that you would be looking for is that you lack the imagination for how to go create things that require software engineers to go deploy like the most advanced tools that they have available to do interesting things for customers. And like I look at my backlog of things to go do, and like I'm not even close to having enough software engineers to go do all of the things, even if I could magically go enhance them all with the most powerful AI coding assistants possible. I do know that like startups right now are like probably hiring smaller initial teams than they were before, just because they're using coding assistants. But like what's happening is like the amount of venture dollars isn't diminishing. Like what I'm seeing right now is like a higher startup creation rate, because like it's actually a better set of bets for venture capitalists to like have smaller funding rounds and like teams who can get more done with fewer people. So like I don't I mean, and this doesn't mean that it's not going to happen, but like I just don't see the structural thing happening yet that is like AI development tools are dramatically reducing the number of jobs. Now, the thing that could happen is if you had a macroeconomic thing that happens and like you got into like hard cost cutting mode, then like obviously you're going to have less of everything then, just because you're being forced by the market to not have as high an expense base as you have. But like right now, it's like there's more interesting stuff to go do than we have the ability to go do it, even if you do have AI coding assistance. And like, by the way, for you all, again, I want as many of you as possible to apply to Microsoft and like big tech companies. But it's also like the best time I've ever seen in my entire life to go start a company. Like, it has never been better.
Let's go to that side. Thank you. 30 seconds.
Thank you. Question on institutional capacity versus individual, ability to do things. Right now, what you talked about, in a weekend, I can go build a pot maker robot, and then I go into a 6-week sprint at work. So institutional processes are built for stability, while individual capacity is exponentially increasing. So how is Microsoft trying to balance those two so that you don't burn out or you encourage some of the young MIT students to kind of join you and they're not kind of intimidated?
Yeah. So sorry, there was like a little bit of echo. So like I'm a little bit hard of hearing. So like I don't know whether I understood all of your question or not. But so was it about like where we have exponentially more capacity to go build new software?
So when you go in on a Monday sprint versus your weekend learning. So in the weekend you have learned so many things, but then you're hit with a 6-week sprint, like you talked about with your friend at the gaming company.
Yeah.
That slows you down incredibly. So
yeah. So look, I think that, and I don't know what the right answer is here. It's kind of a little bit like explore, exploit, right? And like the thing that I would encourage everybody to do is to like have ratios that they set and to like evaluate. Like the thing I would be doing right now, just because I couldn't help myself, is I would have a very, very high explore ratio, and I would probably be underexploiting just because I'm so curious, and like I would just end up wasting a bunch of my time like learning and keeping up with everything that's going on. I do see people making that error right now. Like even though there's a high rate of change, like there's just a bunch of people who are wallowing in the change rather than using it to go do something interesting and new. So like the thing for the curious among you that I would encourage is like just making sure that you are spending some time like using these tools for real. So not just on toy things, but like you're using them enough where you can prove to yourself that you understand them and you know how to do something valuable with them. Even if that means like not being up to day by day date with what's changing. But in whatever case, like you should decide, it's like, okay, it's like 70% exploit and 30% explore, and like see whether or not that's working out for you. But you shouldn't have it set all to one or the other, or you're kind of going to be doomed.
Thank you. Let's go
Thank you,
here.
appreciate.
Please be brief.
I do research on AI governments. My question is, if AI industrialize the human calculation, so what kind of the institution could be transformations, and what Microsoft will contribute on this part? Thank you.
Yeah, again, I'm having a little bit of a hard time hearing.
The question was not clear.
Okay, sorry.
Can you try
I
it
mean,
again?
very simple question is like, if the AI industrialize the calculation our mind nowadays, what institution transformation we need, and how Microsoft could contribute on this aspect?
So it's about institution transformation.
Yeah. So, I mean, so for us, like we've got a very complicated institution. So transforming Microsoft is like it's not a monolithic thing that we're going after. So like the way that I always approach things like this, whether it's Microsoft or a startup or like what I did at LinkedIn, is you have to pick a handful of things inside of your institution that let you get a small team and a small project to go do like an important thing successfully. And once you do that thing with that small team, you sort of expand out. Like what we're doing right now is like our objective is to get I mean, it might sound like a large number, but for us, it's like not. But like, let's call it a few thousand engineers, like fully equipped on like modern tools, who are like working on like the most important parts of the Microsoft stack. And then what that does for you, like when you're trying to do something for real, is it shows you where all of the points of friction are and where all the deficiencies are in infrastructure that you will then need to go fix before you can do the next round of deployment. And so like I think that's like a really good, for institutions, it's a good way of risk adjusting like complicated projects. And it does a couple of things. It identifies like the work that you need to go do for expansion. And it also gives you like in each round of expansion, new experts who you can go deploy onto new things, who have just gotten a victory. It also shows you like inside the company, like what success actually looks like. So you build up some confidence over time.
Thank you. Very, very quick, please.
Hi, I will try to keep this concise. So, as AI tools are becoming more commoditized and easier to access, how are you thinking, as CTO, how are you thinking about sustainable differentiation and maintaining Microsoft's competitive advantage?
Yeah, I mean, it's actually pretty awesome what's happening right now, in that we've got so much progress being made on so many different fronts, on frontier models, on smaller foundation models, on on the tools in the ecosystem that the ecosystems that are arising around these AI platforms. So like our DNA at Microsoft, and this has been true for the entire 50 years that Microsoft has been around, is like we're a platform company, and so we our strategy has always been to give any developer or any builder who's using our technology access to as many options as humanly possible. And like when we don't have an option that our customers want, like we try to figure out how to make those options available on our platform. I think the really, the important thing about what's happening with AI right now, and like we've been seeing this, by the way, for the past 6 or 7 years, is like very reliably the price performance of AI compute, both on the training and the inference side, have been getting better by about 10x every year for the past 7 years straight. And so most of those 10x improvements like have been funneled back into scale up at some point, and some of it's been funneled into price. So like it's actually cheaper now to like go get very complicated things done with AI systems than it was 3 or 4 years ago. And so like we really do see all of this competition and all of the people who are working super hard, and like including here at MIT, like those prices per unit of capability are going down, which just means everybody's going to have more choice, and like we're all going to get to go build more interesting things. And like the way that we think about sustainable advantage is like, do we have a complete enough solution that makes it easy for our customers to build the things that they want to build that like are all coherent? And if we don't have that, then like we go fix it.
Thank you so much. So I'm so sorry the time is up. If you have questions, please send them to me by email, and I will forward them to Kevin, who has another appointment right now. So let's give Kevin a huge round of applause.